Hello everybody, my name is Gabriel Illés and I'm working as a senior DevOps engineer for company Grow to Fit. I'm working for them for several projects. The biggest one is for SentinelOne company. Maybe some of you knows. It's a huge US cybersecurity company, and I'm there as part of the observability platform engineering team. Working on monitoring Kubernetes clusters globally around all of the world. So that's about me. And today I would like to talk about the monitoring in a Kubernetes environment, how it could be if some of you doing some troubleshooting in a Kubernetes, so you know that it could be a huge pain point that find a reason in a Kubernetes that why application is struggling or what is happening, because you have those data in various and separated ways, logs and metrics and so on. So I would like to talk about how it could be enhanced using OpenTelemetry features and using Elastic Stack as a backend for all the three types of the signals. So let's talk about first that why it's so hard to monitor things in a Kubernetes. So first of all, that Kubernetes is a highly dynamic infrastructure. As you know, that pods are ephemeral, IPs are changing, and if we counting also the auto scaling, it's adding another layer of complexity. So it could be really hard to monitor things or observability things in such a dynamic infrastructure. The other issue is that, as I mentioned, the data are in a different backend, so are siloed. So logs and metrics and traces could go to the different backends, and the root cause analysis or troubleshooting is manual and slow work. And also Kubernetes, especially the large ones, have huge amount of data and high velocity. So you can have millions of data points per minute. For example, just mentioning that in the SentinelOne we have a couple of backends, and into the tunnels we have that much that for the minutes we have 40 million time series per minute. So it's really a huge amount of data. Also, what is in Kubernetes playing, that is microservices complexity, that services are interconnecting between each other, and it's really hard to track issues. Also security is coming in. Logs and metrics might contain sensitive information, so you need to secure this data and so on. So Kubernetes has a lot of good points, but in a point of view of the observability, it gives us a complexity that and that's where the OpenTelemetry and Elastic come into play and help us bring some order into that chaos. In the next slide, I would like to talk about basics of the observability. As you know, that there are three types of the signals which are in observability. First of all is metrics, which gives us a high-level picture about the usage of the infrastructure, CPU, memory, then request rates and so on. Then the logs, these are the most detailed data, and you can show what's happening with your application or on the infrastructure level. But they are high volume and harder to query without structure. And the third type of data are traces. Traces helps us understand the distributed systems. They show the full journey between the request from your application through the microservices, and that you can identify the latency or some hotspots for broken links. So used together, these three pillars drastically reduce the mean time to insight, helping you not just detect the problem, but understand and fix it faster. Let's talk about a little bit about the OpenTelemetry. I know that there was a couple of presentations yesterday and today that around the OpenTelemetry, so I don't want to give you information which you already know. Just refresh that the OpenTelemetry is an open source and vendor agnostic framework for collecting those observability data. It has some components and created under CNCF project. The SDK can use to instrument your application, and the collector is a main component of the OpenTelemetry, where you can collect those data. And also it's vendor neutral and so on. So just refresh that what is the OpenTelemetry. The next component of my presentation is the Elastic Observability Stack. So this former known as a ELK stack, but has some new features, for example, the Elastic APM server and so on. And the main component is the Elasticsearch, which is a fast querying and analytics engine. Kibana is used for the dashboards, and also you can detect anomalies using the machine learning feature of the Elastic stack. The Elastic APM is natively support the OpenTelemetry through the OTLP protocol, and Logstash and Beats help ship the transform telemetry data. And also another component called ILM, which manages storage, long-term storage with different tiers. So this new Elastic stack is bringing everything into the single pane, where you can store traces, logs, and metrics aligned with the OpenTelemetry, and it scales well in a Kubernetes environment. And yeah. So next slide, I would like to present that this joint architecture in a high level, that application is instrumented with OpenTelemetry SDKs and sending the signals to the OpenTelemetry collector. And in the collector, you can use processors to enrich the data and so on. And this collector could be deployed in a Kubernetes cluster as a daemon set or in a standalone way. It's up to you that how you use it. But later I will show you the demo where both of the type of deployment is used. One is used for collecting data from the application itself, and deploying OTL collector as a daemon set, you can collect data from the infrastructure, from the underlying nodes, and other things. And the last component is this Elastic APM server and the Elasticsearch, which is storing your data, and using the Kibana brings everything together. You can create dashboards which are containing your data with metrics, traces, and logs side by side. And this setup is modular, scalable, and entirely vendor neutral. It's ideal for the Kubernetes deployment. So let's talk about some key benefits of this architecture. It's provide a unified telemetry pipeline. So you have only one data pipeline for all the three types of the signals, which are logs, metrics, and tracings. No need any other tools. So you have only one backend. And as I mentioned before, that is vendor neutral and open source. You're not locked in any vendor, and it's natively scalability and scalable and works well with the Kubernetes. And lifecycle management can take care of your data with the storage tiering as a cold storage for older data, and having the fresh data in a warm storage or hot, and so on. So let's switch to the demo, which I mentioned. So here you can see those two codes. One is the GitHub repository of this OpenTelemetry demo from Elastic, and the second one is live demo is up 24/7. So you can check it how it is look like. I can show you some also switch to that. This demo is using the also mentioned in previous presentations, this OpenTelemetry demo, which is the astronomy shop application with microservices, and those microservices are instrumented with different languages. There are 10 microservices and instrumented with different languages, which provides traces, metrics, and logs. And it's widely used, this demo, for testing observability and just playing around with the things that you can try it out and even develop something around it. So this is basically the architecture of this demo. That application is sending the data through the OpenTelemetry collector, and as I mentioned, this OpenTelemetry collector is deployed in two ways in a Kubernetes cluster, as a deployment and also as a daemon set. And you can see those building blocks. There are some processors in the hotel collectors deployed as a daemon set, which are collecting metadata from the Kubernetes environment and enriching all the data with those information. And also these processors are used for the same adding same information into the data sent from the application. So basically creating a correlation between those signals, and using the Elasticsearch and Kibana, creating dashboards, you can easily track the things what is happening in an application. This is some screenshots from the demo. So basically this is the architecture of this OpenTelemetry demo application. You see that those components running as a microservices and the connection between the services. And if you go further into that, you can choose one of the services and get more detailed information from traces and logs. And also you can use this machine learning feature from the Elasticsearch that can analyze anomalies, and you can get more information from it. So maybe I can switch to, as I mentioned, I already. Okay, so it's not sharing. Can I switch between the desktops? Okay, so maybe I just.
Prehodík na duplikovanie tých obrazoviek, ak tam chcete ukázať.
Tak tu môžem to navodiť na desktop. A môžem toto šerovať, ďalší desktop?
No, to je ale stále extendnuté, čiže...
Aha.
Cez display... A toto dáme, že... Magic je...
Alebo môžem to dať na ten predošlý.
Oh, wait a minute, there's some technical issues. So.
Sorry for the delay. Thank you. Okay, so here you can see this live demo on that URL. So here is the overview, and if you go to the application and the service inventory, the service map, so you can see in live that the current status of the applications, which services are running, and in the inventory you can see the list of the services. And for example, if you go to the front end, you can see the data coming from it, and you can check other signals, for example logs. Okay, so I'm not very much familiar with this. But we can go to the traces, for example, check the HTTP GET. So basically you can see that you can switch, using this Elastic search and Kibana, you can go through all the type of the signals and have it in one place. So if you would like, you can play around with it. The GitHub repository is well documented, and you really just out of the box demo. You can deploy it on any Kubernetes cluster, and you can play with it. So let's go back. So let's talk about some cost and performance optimizations tips for this architecture. So about sampling and downsampling the metrics. So basically, if you need to or you have to reduce the cost and optimize the performance. So the tail-based sampling is keep only traces that matter, errors, slowness, anomalies, and metrics. Also, downsampling the metrics can reduce the storage and usage and make this architecture cost effective. As I mentioned, the lifecycle management of the Elasticsearch is using the different tiers for the storage. And also the cardinality of the metrics, and so don't collect metrics with a high cardinality using like user ID or UID or something like that. It also could do reducing the costs drastically, and configure the collectors to drop or buffer the data when the backend is slow or not reachable. And it's best practice to test this behavior before you go for the production. Okay, I switched the slides. So what are the key takeaways, so that really this architecture, you can have only one pipeline for all the types of the data, and you can manage them in one UI. And I know that it could really help, for example, for the operations team to improve the troubleshooting of incidents and issues in a Kubernetes way, in a Kubernetes environment. So, yeah, basically that's all. Thank you. So.
So can we ask for a slide on the...
How can I switch? Okay, so what about storage consumption compared to, for example, PLG? In past days, there were very high difference.
Maybe I can read it for the recording. So what about storage consumption compared to, for example, PLG? In past days, there was a very high difference.
The storage consumption, as I mentioned, it depends on that how many data you are sending to it. So if you would like to have all the data, so it will cost you on side the storage. It could grow huge, as also in some other presentations here today was talk about that you can reduce the amount of the data, filtering out only just the metrics which have meaningful insights for you, and also the sampling for the traces. If you need more data, you can configure it back that, for example, you will collect, if you have struggling with some performance issues, you can increase the amount of the data, for example, for 24 hours and investigate the issue on the environment. But if you would like to have good insights, or it takes cost because it takes more of the data. So I'm not sure if enough answered this question.
I think we can move on. So another one is, how do you deploy Elasticsearch? If you are using the Elastic operator, how do you address the security concern that one of the init container requires privilege mode?
Currently, we are not using this Elasticsearch, but what I searched that you can use, for example, this Elastic Cloud deployment in a Kubernetes cluster, which has these CRDs, and you can deploy the components of the Elastic Stack as CRDs. And about the privileged mode, init containers, it depends on the security of your environment. So if allowed to have some init containers with privilege mode, you can use them. But if not, then you need to find some workaround or in other ways. So it's really hard to say. It depends on the use cases. If no more questions, then thank you again.